Hey, just recording the video for lecture 6. I forgot to record the live lecture during class, so I'm just going to do one more lecture now and record it. Normally in these videos, you'll have time to answer the questions and do the discussion prompts as the rest of the class is doing them. For this video, just when I tell you to pause the video and work through it by yourself, please do so that you actually practice putting all these concepts into practice. All right, so overview for today's class. We covered numeric and string operators. Then we'll do a Kahoot. I'll show the Kahoot questions in this video. We'll go into relational operators and then finish off with code flowcharts. So starting off with numeric and string operators. Let's start with the plus operator. So take a second to pause the video and try to guess what the output is going to be for each of them. So what's the value of sum at the end? What's the value excuse me, what's the value of concat, and then what's the value of sum when it's doubles. So pause the video. Okay, I'm back with the answers. So for the int, the answer sum is going to be 8 because num1, it'll see the value is 5. Num2, it'll see the value is 3. And then it'll put it together to get 8. The double will also be sum is equal to 8. And then the string, this is an interesting one. So we kind of talked about it in the last class, but with string, the plus symbol actually works as a concatenation symbol. So it just merges together the two strings. So for string, the answer is going to be 53 because it'll take the 5 and then it'll add 3 at the end. This is very similar to what we talked about at the end of the last lecture, where you can think of when it's string, you can almost think of it like on a jersey where we're just putting together this string of characters to make one larger string of characters. It doesn't do any numerical mathematics and combine them to make 8. It just prints 5 and then 3. Okay, minus operator. Again, take a second to pause. Okay, I'm back with the answer. So sub, it'll work similar to plus, except we're going to subtract the two numbers. So num1 is still going to be 5, num2 is 3, and we have 5 minus 3, which is equal to 2. For string, this is actually going to throw an error. So the only string operator that works for strings, the only arithmetic operator that works for strings is the plus symbol. The others are just going to throw an error because how do you subtract the 3 character from the 5 character? There's no way to remove it. And then for double, it'll be like ints here, whereas sub is 2. Multiplication operator. This is indicated by the star symbol, or the asterisk, shift 8 on a lot of keyboards. So again, I'll pause the video. Okay, I'm back with the answer. So num1 times num2 will be 5 times 3 is 15. As we talked about on the previous slide, you can't do multiplication with a string, so that's going to be an error. And then for double, we're also going to have mul is 15. Now this next one is a little bit more complicated. So if you haven't already, make sure you pause the video and try to come up with the answer for each. Okay, I'm back. So int division, 5 divided by 3. Normally we would expect the answer in real life to be 1.6667. But because both values are ints, this is going to end up being int division. And so that means the decimal is going to get dropped, and we're just going to be left with the value 1. For string, it's still going to be an error. And then for double, so it looks very similar to the int case, but now decimal 1, decimal 2, they're both doubles. And so now we have double division. And when we have double division, the decimal is kept. And we're given div is 1.667. So this is again what we call operator overloading, where the same operator acts differently based on what the data types are. So, if both values are ints, then it does int division, and it gives a different output. If at least one of the values, what we call the operands, are doubles, then it will do double division, and it will give us a decimal value. And if one of the operands are a string, then it's going to be an error. So it's kind of cool how the same operator, this / symbol, does 3 different things based on what the data types are. Finally, we're left with the modulus operator, which we learned last lecture is a remainder. So when we do 5 divided by 3 in int division, that gave the value 1 with a remainder of 2. So if we were to do num1 mod num2, we just have that mod is 2. And this remainder is very useful for problems like converting from height, where if we had like 68 inches and we wanted to convert it to feet in inches, we can do 68 divided by 12. That will give us the value 5. And then 68 mod 12, that will give us the remainder, which would be 8 inches. So 68 inches is 5 foot, 8 inches. For string, it's going to be an error. And then for doubles, it is also going to be an error. So this modulus operator only works if both data types are ints. Cool. So that's 5 arithmetic operators. And we've also already been using 3 operators. We just haven't formally defined them. So the first one is what we use to print to the console. So these 2 less than symbols put together, that's what we call the stream insertion operator. And that's used to insert a stream of characters into the console for the user to see. The second one is these 2 greater than symbols that we've been using with cin, and that's called the stream extraction operator. And essentially that extracts data from the console and puts it into a variable. The final one we've used a lot, and this is when we want to assign a value to a variable. So it's the operator, the equal sign, is aptly called the assignment operator because it assigns the value on the right side of the equal sign to the variable that's on the left side. So in total, we've already learned 8 operators in just 2 weeks, and we're going to learn 6 more later this lecture with relational operators. So we'll have already learned 14 operators, and I think in total this semester we'll maybe learn 20 total. So we've already made tremendous progress. It's okay if some of them are a little bit confusing, but the best way to remember them is to practice, right? I could have shown you this table at the beginning, and I think it would have been kind of confusing. But hopefully you've now done so many cout statements that you've gotten used to doing the 2 less than symbols. Or if you haven't in lab and homeworks yet, you will, starting to use cin and using that stream operator. And then obviously with creating variables, we'll be doing variable assignments throughout this entire semester. And so we'll give you practice with these operators and even the 5 previous arithmetic operators. I'll have you do problems that involve adding numbers or multiplying or dividing or getting the remainder. So don't worry about memorizing the exact definitions. We'll practice a lot. Kahoot. So in class we did a live Kahoot. The questions were pretty hard. I think first place in both classes only got 5 out of 7 right. But I think it's a good indication of kind of the difficulty we hope to get to by the time exams come in September, at the end of September. All right. So let's see if I can start a game without actually requiring people to log in. There should be an edit button. Okay, that's kind of annoying. Oh, here. Okay. Okay. So what is the output of the following code? Pause the video, and then I'll explain it. Okay, I'm back. So let's step through it. We define all our variables at the top, so that looks good. Num1 is 2, num2 is 5. So at this point at line 8, we see what num1 is. That's equal to 2. Num2 is equal to 5. And then this star is the multiplication operator. So output is going to be equal to 2 times 5, which is 10. So the answer for this question is blue, 10. pause the video, make sure you get your answer before you continue. Okay, I'm back. This one's a little bit complex. The answer is random number. A lot of students in the class put error, which is on the right track. Let's see what's actually happening. So we define the variables total and tax, which means we create a memory spot for it, but we don't assign any values to it. For tax, we assign a value to 10, and then at line 7, when there's an assignment statement, the expression on the right evaluates first. So tax is going to be equal to 10, and it gets added to total. But what's the value of total at this point? Because we haven't assigned it, it just takes on a random number. Like we defined the variable, so there's something there. We assigned a memory spot, there's something there, but we don't know what it is. And so we're adding 10 to some random number, and that will then be stored in total. So when we print out total, it's going to be a random number. Okay. Pause the video. And I'm back. All right. Very similar problem, except now we assign a value to total. So we come to line 8, and again, the right side of the equals operator will evaluate first. So what's the value of total? At this point, it's 25. What's the value of tax? It's 5. So 25 plus 5 is 30. And now we go over to the left side. So now we have total is equal to 30. So the previous total value of 25 gets erased, and we replace it with the value 30. So now at line 9, when we print it out, it's going to be 30, and the answer is blue. Pause the video. Okay, I'm back. This one, we see the plus operator, and so now we have to see what the data types are. Word 1 is a string. Word 2 is a string, which means that we're going to be doing concatenation, which means we just merge the two strings together. So the answer is going to be blue here, hello 5, because this 5 just gets merged onto the end of hello. Pause the video. Okay, I'm back. This one was super tricky and was probably the most missed problem on the quiz, on the Kahoot, but people immediately kind of figured out why their initial answer was wrong. And that's because we define num1 and num2 as doubles, but the value we assign to it is actually a string because it has the double quotes. So it looks like a decimal number, but because there's quotes, it's actually a string. And so because we're trying to assign a string to a double, we get an error. So the answer for this one is green. Okay, pause the video. And I'm back. So for this one, num1 divided by num2. To figure out what the division operator is doing, we have to see what the data types are on num1 and num2. And in this case, based on line 5, num1 and num2 are both ints, so we're going to be doing int division on the right. 3 divided by 2 is normally 1.5, but because we're doing int division, we drop the decimal, and we're just left with the value 1. So the correct answer for this one is the yellow box, the number 1. Okay, last problem. This one is very similar to the previous one. Pause the problem if you need. Okay, I'm back. This one is very similar, except now the main difference is in line 6, where num2 is actually a double instead of an int. So when we look at this division operator, we see what the operands are. Num1 is an int, num2 is a double. Because one of these two operands is a double, we're going to be doing double division. So 3 divided by 2 gives us 1.5. We store that in the double output, and we print it out. So the answer for this one is blue, 1.5. And then the final question was just a poll, just seeing how people are feeling. Okay. So now we're going to move on to the next topic, relational operators. I would have try pausing the video and just trying to guess what each of these 6 operators does. Okay, I'm back. So the first one you might have seen in an algebra class, it's the greater than operator. So we're essentially checking, is x greater than y? If x was 8 and y is 5, then yes, it's true, 8 is greater than 5. The next symbol is the opposite, it's less than. So is x less than y? If x was 2 and y was 5, then it would be true, that 2 is less than 5. The greater than or equal symbol, so is x greater than or equal to y? So again, in our example, if y is 5 and x is 5, that would actually be true because x isn't greater, but it's equal to y. And if x is still greater than y, then it will still be true. And then this one's the opposite, less than or equal to. So we phrase that as, is x less than or equal to y? This next symbol might be new. You wouldn't have seen this one in an algebra class. The double equal sign. That's just to signify the equals operator, is x equal to y? And I want you to think about why we couldn't just do x is equal to y. Why did we need 2 equal signs? It's because if we just did x is equal to y, that would be the assignment operator. So it would take whatever value is in y and it would assign it to x. So the reason why we need 2 equal signs is to distinguish from the assignment operator. And then this last symbol will also be new outside of coding, and that's the not equal sign. So another way of thinking about that is x different than y? If x is different than y, then the answer is true. So let's do some practice. Let's fill out this slide. So I want you to think about it as I'm typing this out. First, how you would say it. So this one is asking, is 12 greater than 5? It is, so that's true. This next one is 7 less than or equal to 5? And it's not. So the answer for this is going to be false. For these next 3, let's pretend earlier in our code we assigned the variable x to the value 10. And then what will these 3 be? So is x greater than or equal to 10? Yes, it's true because x is at least equal. If we just had it like this, x is greater than 10, then the answer would be false. So that's where having this equal sign can be critical for these kind of cases that are right on the border. Okay, is x not equal to 8? Or another way of thinking about it is x different than 8? And this is true because x is 10, and 10 is different than 8. Then the last one, is x equal to 8? No, again, x is 10. That is not equal to 8, so this one will be false. Okay, we skipped the live coding in class, and we finished off with code flowcharts. So let's say we had some sample code. Let me go into my Scratchpad. Okay, so this program is relatively straightforward. A user walks into the bar, and the bartender says, "Welcome to the bar, what's your age?" And the user says maybe what their age is, and then the bartender just says, "Wow, you are 23 years old." And it's able to print out 23 because we stored the user's input into the variable age. So the matching flowchart for this code would just look like this. A flowchart is a way to visualize the execution of a code. And in our case, it's very linear. We start at the top of the main function, we ask the user for their age, and we store that data, and then we print the user's age. And then that's the end of our main function. Pretty straightforward. But what if we wanted to do different things based on what the user told us? So in this bar example, we again ask the user for their age, and we store the data, but now we say if age is greater than or equal to 21. If that statement is true, then we ask the user what drink they want, and then once we're done with that, we come back to the main flow, and we just continue with whatever the code does. So in this case, it just prints the user's age. So that's one flow, that's one branch the code could take. The other branches, we again ask the user for their age and store the data, we come down here, and let's say age is not greater than or equal to 21. Then the code just continues, And then we just print the user's age. So this is the flow chart. Let's see what it looks like back in code. So we're going to learn about if statements on Wednesday, but I just want to introduce it to you now so you have a little bit of time to, have it in the back of your mind before Wednesday's lecture. And here we can say if age is greater than or equal to 21, then we'll print out what drink do you want? So now let's run the code. Again, we put in 23. This is greater than or equal to 21. So the bartender is going to ask us, what drink do you want? We can get input from the user if we wanted to keep it going, but for now we'll keep it simple. And then it's still, the code doesn't end at line 10. It does that, and then it comes back to the main flow and prints, wow, you're 23 years old. So that's one branch. But let's say we tried it again, and this time we said the age was 18, so something that's less than 21. In this case, everything inside these brackets won't run because age is not greater than or equal to 21. So instead, it's going to skip line 10, and it's just going to go down to 13 and say, wow, you're 18 years old. Cool. So we're going to go into this in way more detail on Wednesday. I just wanted to introduce it now so it's in the back of your mind. But don't worry about memorizing it now. We'll practice on Wednesday. Finally, what's due for this week? Homework 0, attend office hours in the first 2 weeks. Your last chance to do this now is going to be Wednesday from 2 p.m. to 5 p.m. These should be the easiest 5 points you get all semester. It only takes 2 minutes, so please come in and do it. Homework 1, due tonight. Lab 2 is going to be due Wednesday at 5 p.m. Cool. That's all I have now. I'm going to end the recording.